This is problem 22 of chapter 11. It's another simulation example. And so we have a person with type O blood can receive blood only from other type O donors. Okay, so that's kind of critical. And so about 44% of U.S. population has type O blood. At a blood drive, how many potential donors do you expect to examine in order to get 3 units of type O blood? Okay, so let's see. The thing that's repeating over and over again on this particular problem is a donor. So each donor is a component. Alright, and so the outcomes would be they either they have type O blood or not type O. And it looks like for type O blood there's a 44% chance, which means, let's see, there's a 56% chance that they're some other type. Alright, so what are we going to do? It looks like we should probably use 2-digit numbers. So we will use 2-digit numbers to represent people with type O and not type O blood according to the following assignments. So what we're going to do is we're going to say from 0 to 43 is type O, and from 44 to 99 is not type O. Okay? So we're going to count the numbers. The donors. Right? We're going to count the donors until we get 3 people with type O blood. Okay, so each person is mutually exclusive from the other, so we don't have to worry about repeating numbers. We don't have to ignore any numbers. And let's see, we count them until we get 300 and stop at that point. Alright, so the response variable is the total number of donors required to get 3 type O donors. Okay, so it might sound a little bit redundant, but if the simulation gets more complicated, this kind of detail is necessary. So we want to get into a good habit. Okay, so our notation, I'm going to just say O means type O, and and N means not type O. Okay, so let's do some trials and see what happens. So trial 1, we're going to 43. So this would be N, right? N, and then 5 would be type O. Okay, and then 6 would be type O, and then 85 would be not, and 69 would be not, 82 would be not, 45 would still be not, 43 is the cutoff. Ooh, 44, close, but no spaghetti. Okay, and then finally, bingo. Alright, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. And I'm going to start again with trial 2. And we got no, no. It doesn't look like an N, does it? No. 56 is a no. 96 is a no. I did it again, didn't I? 42, just barely made it. No. And no. And yes. And yes. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so obviously I should do this about 10 times to get an accurate number. Because this is a video, I'm going to just sort of cut it short right there. So my number of trials is 2. So our statistic, the average, 9 plus 9 divided by 2 is 9. What a surprise. Okay, so that it would be the average. Okay, so label your statistic. So let's see, according to the simulation, we expect to need 9 donors on average to get 3 donors that have type O blood. Okay, so that's how you do this problem. Now I just want to comment on one thing. This question didn't, it said blood drive, how many donors do you expect to examine in order to get 3? So if they said how many donors do you need to ensure that you get 3, that's a different question. If they say ensure, let's say that we, if we had a 9 and a 9 and an 8 and a 15 and a 4 and a 17 and then another 9. Okay, well then we would take the biggest number. We would say, okay, to be sure, then we would plan on 17. Okay, the average might be 9, but we would take the maximum for that kind of question. So I just wanted to point that out. So you have to really look at the question to determine what kind of statistic to compute, what kind of statistic you want to compute to answer the question. All right, I hope that helps. Good luck.